Alright, so this is the video on centers of gravity from Chapter 7. We start by reviewing weights of force, okay, and it is the mass times g. G is the acceleration due to gravity, 9.8 meters per second squared, okay. Weight we treat as a parallel force system across the surface of an object, okay? So the distributed load is the resultant, and we call that the weight. Alright, so let's look at these equations that represent the center of gravity, okay? Weight is the sum of all the little weights at all the individual points, okay? And so we have the equation just like previously on distributed loads, where the total weight, W, times x bar is equal to the sum of the little weights times their x location. Alright, so that would be its x location. Alright, and here's its y location. Alright, so y bar is equal to the sum of the little w's times the y, all divided by the total weight of the object. Alright, anytime something has a line of symmetry, the center of gravity is going to lie on the line of symmetry. So if we look at this circle, there's a line of symmetry here and one here. Okay, so it's going to lie on both of those lines of symmetry, and that is this point right here in the center. Okay, if a plate has two perpendicular lines of symmetry, the center of gravity will be at the intersection of those points. Okay, so this is example 7.1 from your textbook. Alright, and we have a 10-inch diameter sphere. That sphere is made of steel. Okay, just so that you're sure you know. Okay, and it's sitting on top of a concrete pedestal, and we are supposed to find the y bar. Right? It is symmetrical about that y-axis, so we only need to find the height, okay, where that will where that center of gravity will fall. Okay, so to begin with, we need to go to Appendix G in your book. Okay, and there you'll see a table that's on page 603, okay, where you can find what's called weight densities. Okay, and when we look at that for steel, alright, steel has a weight density of 490 pounds per cubic foot. Okay, and concrete, which is the pedestal, has a weight density of 150 pounds per cubic foot. Alright, so now what we need to do is begin to actually compute the individual weights of these pieces. Alright, so to do that, we need to get the individual volumes. Alright, so let's make this piece 1, and let's make this one piece 2. Okay, so for piece 1, okay, the volume is going to be length times width times height. So the volume of piece 1 is going to be 1 foot times 1 foot times 1.5 feet. Okay, and that is going to be equal to 1.5 cubic feet. And then, so the weight of piece 1 is going to be 1.5 feet cubed times the weight density for concrete, and that was 150, oops, here it is, 150 pounds per cubic feet. Okay, so now if I want to find the y bar of this rectangular prism, okay, if I just think about the rectangle, the center of gravity of a rectangle would be halfway up that height, right? So y1 is going to be equal to half the height of that 18 inches, or it's going to be 9 inches. Okay. Now if we look at piece 2, alright, the volume is going to be equal to 4 divided by 3 times pi times r cubed. And that's the equation for the volume of a sphere. Okay, so then that is going to be equal to, let's do it this way, it's going to be equal to 4 divided by 3 times pi times 5 divided by 12 feet. Alright, 5 inches divided by 12 inches would give us feet. Okay, cubed. So that works out to be, let's see, 303 Alright, so then the weight is going to be equal to, that's 2, not 1, 0.303 times the 490, and that pounds per cubic foot, this number right up here for the weight density, and I get 148.5 pounds. Okay. Then, alright, let's see, so y2, okay, the center of that sphere is right here at the center at 5 inches up into the sphere. Okay, but first we have to add 18, so that is 18 plus 5, so it's equal to 23 inches. Okay, so now if we want to find y bar is going to be equal to that W1 times Y1 plus W2 times Y2 that whole quantity divided by the total weight. Okay, and so that makes y bar equal to, so the is equal to, oops, I didn't actually show you that before. It's 225 cubic feet. Times 9 inches plus 148.5 times 23 inches, that whole thing, divided by 225 plus 148.5. Okay, when I plug all that into my calculator, I get a y bar equal to and I get a y bar of 14.6 inches. Okay, this 225 comes from right here. Right? Okay, so that's the answer to that problem. Let's look at example 7.2 now. Right, in this case, we have all these boxes being loaded on an airplane, and we need to know where the center of gravity is for them. So the first thing we need to do is convert all these masses to weights. Okay, and so I'm just going to follow the nomenclature they have here and give you those weights. The weight of the first block is 4,900 newtons. The weight of the second one is 3,430 newtons. The weight of the third one is 1,960 newtons. The weight of the fourth one is 7,840 newtons. And then the weight of the fifth box is 6,860 newtons. Okay, so the total weight is equal to 24,900. Oops. 24,990 newtons. Okay, so now X bar is just going to be equal to 4,900 times, now this is quantity, parentheses in there, okay, 4,090 times half of this 4, okay, that's 2 meters. Alright, then plus 3,430 times the 4 meters plus half of that. That's going to be 4.5 meters. Okay, plus 1960, now we're doing box 3, times 4 meters plus 1 meter, 5 meters, plus half of the 2. So that's going to be 6 meters. And then the next one is going to be 7,840 newtons times, that is going to be 7 meters plus half of the 3, 8.5 meters, plus the last box, that's 6,860 times, okay, let's see, this is 5, this is 8, this is 11, plus half of 3 is going to be 12.5. Okay, and that whole thing is going to be divided by 24,990 newtons. So when I get to that, I get x bar is equal to, let's plug that in, okay, let's just double check these numbers one time. 4,900 times 2, that's half of the 4, times 4.5, that's correct. Then this box is going to be at 5 plus half, that's 6. This is 7,840, okay, and it's going to be times okay, that one should be 5, 7, that's 8.5 meters, and then this one is, let's see, we've got 4 plus 3 plus 3, 10. Oh, that one's 11.5. There we go. Something didn't seem right, but I couldn't figure out what it was. Alright, let's double check that. That's 5, that's 5, plus half of that, 11.5. Okay, so this works out that when I do it, I end up getting about 7 point, let's see, I get 7.30 meters. Alright, so that finishes us up for center of gravity, and here's the summary. Okay, you need to sketch the members and put all the dimensions on it. Okay, make note anytime you have an axis of symmetry, divide each member into component parts. Okay, and then find x bar, y bar, and z bar. Alright, so up next we will have centroids and centroidal axes.